Welcome to another video. In this video we are going to solve problem number 105, that is construct binary tree from preorder and inorder traversal. Consider this problem. In this problem they will give preorder and inorder traversal of a tree, binary tree, and we need to construct this tree and we need to return root pointer to the tree. So this is what problem statement means. If you consider this first example also, here it is here they have mentioned the preorder traversal and here they have mentioned inorder traversal. We can go through some examples to understand how to write preorder and inorder traversal. Then we can come up with this solution. Let's consider this given tree which is described in the first example, and we will go through this how to do a preorder traversal, and then we will understand how to write inorder traversal. This is important to understand because from this we can easily write that solution how to construct tree given these two traversals. In preorder traversal, first we will process the root node, and then after processing the root node we will go to left subtree, and then we will process the right subtree. This is the approach. Whenever we process the root node, I am going to write the value. So in this way we will start from the root node. Since we process the root node, I am going to write 3. Then we will move towards the left. When we move to the left, here also we will start with the root node, and after processing 9 we are writing 9, and in the left and right subtree are empty, so we will return to the caller, that is tree. Since root and left is done, and now we are going to process the right subtree. So whenever right is called, we will come to right subtree, and here also root will be processed first. So we are going to write 20, and then we will move towards the left subtree. When we move to left subtree, here also root will be processed first. Whenever root is processed, I am writing those values, and the left subtree is empty, right subtree is also empty, and here we will return to the caller, and we will move towards the right subtree. When we process this root, I am writing that 7 value, and then we are going to process the left and right subtree of 7 which are empty. So this is the way how we are going to write a preorder traversal. This is the actual way how recursion actually works when you call it inside a 3-line function, because most of the time we write those functions and we don't really visualize how it is actually working. So this is the way how it is going to work. And similarly we can go through we can consider the same tree and we can do a inorder traversal, and I am considering the same example, and here also we are going to do a inorder traversal, and we are going to write how we are going to process. Whenever root comes, we are going to process. That means, so in inorder traversal we are going to process the left subtree, and in inorder traversal we will start with the left subtree, and then we will process the root node, and then we will process the right subtree. And when we start from the root node, it calls the left call. So when left, here also we will try to process the left, there is nothing, so then we will call the root. So 9 is processed, I am writing 9, and after that it will process the right subtree. Since it is empty, nothing is going to happen. Here also it will return to the caller, and we will process the root node, that is 3, and then it will go to the call will go to the right subtree. Here also when we enter this node, we will call processing the left subtree. Here also we will call the left subtree. Since left is empty, we will return and root will be processed. So I am writing 15, and then right. This is the process. You have to understand how inorder traversal works. Once you are familiar with writing this solution, you can understand lot of other solutions which are based on tree traversal. So if you are understanding this recursive calls and how it is going to return to parent function, calling function, then it will be very easy to understand the solutions which are based on tree traversal. Now we are very familiar with inorder and preorder traversal, and let us try to analyze how we can construct a tree when both the traversals are given. So I'm going to consider the same example which is present in the first example. So this is the given tree, and here I'm just going to write what is the preorder and inorder traversal directly. But by this time you have already understood the process how to write preorder and inorder traversal by going through a recursive calls. So these are the input parameters which are given in the function in the problem statement, and we need to construct this tree. So there are a couple of things we should be familiar by now. In the first node will always be a root in the preorder traversal. Whenever we do a preorder traversal, we will always process the root node. Once we get the root node, then we have to find that root node in the inorder traversal, because then we can split that inorder traversal into right subtree and left subtree. So now once we find that, we can split inorder array into left subtree and right subtree, and we can also get to know how many nodes which are present in the left subtree. Then it is very easy to split it into a new problem, and we can call these functions recursively. So this is the approach that we are going to follow to solve this problem actually. So we need to split. It is very easy to split the inorder array because we will find the index of that root node, and we will split it into two parts. In order to split the preorder array, we need to know number of nodes which are present in the left subtree. So that can be easily computed, which is equal to index of the root node. So these are the things. If we understand these things, then writing that particular solution is very easy. And I hope you understood this technique, and let's see. Let's implement that same solution that we have discussed here. So one more thing that we need to keep in mind is they have in the constraint they have mentioned that preorder length will be more than 1, so we don't have to check anything, and inorder length and preorder length will be equal, and they have also mentioned preorder is guaranteed to be preorder traversal of the tree, and inorder is guaranteed to be inorder traversal of the tree. And one more important point we should make a note here is preorder and inorder consists of unique values. Why this is important is once we make the first node as a root node, then we are going to find the index of that particular node in the inorder values. So from the preorder array, we are going to make first node as the root, and then we are going to find that index where it is present in this inorder traversal. So in that case, if tree does not have unique values, it will be of different problem. So we need to keep those things in mind, and let us start writing the solution. Anyway, they have mentioned that preorder and inorder length will be at least 1, so we don't have to check the length. We can start with the root node. Root node will be equal to, we have to create a new node with the value of preorder of 0, because this is the first element which is present in the preorder traversal. So once we have the root node, then we need to find index of root in order. So index of root node in the inorder, this we can find it by using this inbuilt index function inorder.index of preorder of 0. Now we know the index, then using this index we can split inorder and preorder traversal, and we can make this as a subproblem where we call this build tree function again with those parameters. So to the left subtree, root node left, will be equal to self dot build tree of, we need to pass pre-order for this left subtree. So pre-order for this left subtree, let us consider this example. So we will make 3 as root and we will find this index. So for the left subtree we need to pass what is the pre-order. Pre-order will be just this value because there is only one node which is present in the left subtree. That we got to know by this index. So what we are going to do is we are going to slice that pre-order array. 0th index has already made the root, so we are going to consider it from 1 to till how many values we need to consider. We need to consider this index of, we are going to name it as something simple because it will be easy. Root index, we are going to name it as root index, and we are going to make use of root index plus 1 because this slicing will take range from 1 to root index. If you mention root index plus 1 while slicing, it will not include this last index, so that's why we are using this plus 1 while slicing. And for the left subtree, what will be the inorder traversal? We need to slice that one as well. So inorder will be from the beginning to the root index. We don't have to include that root index, but from the beginning we need all the values. So similarly, what will happen to the right subtree? For right subtree, we will call the same function recursively. We need to slice the pre-order. So we know the root index and we also got to know, and it will be for what will be the pre-order. Pre-order will be from this index, actually wherever we stopped. So root index plus 1 till the end, and inorder will be, so for the right subtree we are going to take this from root index to, so anyway root index is already done, so root index plus 1 to till the end, and finally we are going to return root. Let us submit this solution and check whether it passes the initial test cases. Okay, index out of range. That means we have some, maybe we are getting some 0 values. So what we are going to do is we will check. If not, since we are calling this function recursively, we need to check or not of inorder, then we should return. So let's run this solution again and check whether it passes the initial test cases. Yes, it is passing the initial test cases. Let us submit this solution and check whether it passes all the test cases or not. Yes, as you can see here, this solution is passing all the test cases. Only thing in this solution, it seems complex, but if you have understood how we are splitting these arrays into a new subproblem, then it will be very easy, because this root index represents the index of root node in the Inorder Traversal. So once we get that, we will split this array into 2 parts, and we will also split this array into 2 parts and make it as left and right subtrees. This is all we are doing. I hope you like this video. If you are interested in learning more about other data structures and algorithm related problems, please check out other videos from my channel.